I'm at critical temperature. I hold it, let's say I'm gonna do 2000, I hold it for 15 minutes. I pull it out, put it between my plates, quench it, okay? From there, it goes into my tempering oven, all right? And it is 2 hours. I'm gonna pick 400 degrees, okay?
Yeah.
But it has to be taken out. You have to do 2 tempers, and in between those, it has to come to room temperature, correct?
Yes, correct.
Why does it have to be room temperature before it goes back into the second tempering?
Okay. Basically, what's happening with a lot of these steels, the higher alloyed steels, when you quench to room temperature, you're getting a certain percentage of martensite, and it's untempered martensite. It's very brittle. And depending upon the steel and how highly alloyed it is, you're going to have some what's called retained austenite in there. So, the first temper, its primary purpose is to temper back the untempered martensite, which is very brittle. That's what that first temper does. But also, during that first temper, some of that retained austenite transforms to untempered martensite. So now you've got a steel that may have 85, 90% tempered martensite. It may have 5% untempered martensite, which is brittle. And then the balance, you could still have some retained austenite in there. So that second temper tempers the untempered martensite that you got from the first temper. But going all the way down to room temperature is just as meaningful or critical as when you quench down to room temperature. In between tempers, you got to go to room temperature so that everything can complete all those transformations. But that first temper tempers the untempered martensite, which you've got a lot of, very brittle, and some of the retained austenite transforms to untempered martensite. So that's why you're doing a second temper. You're tempering that untempered martensite that transformed during the first temper.
So instead of putting the blades directly into the tempering cycle, let's go back and say, all right, we just took the blades out of the oven, put it between our plates, we just quenched it. Now we could talk about cryo, okay? We could snap temper, which is just throwing the blade into an oven, just do a quick tempering before it goes into a cold treatment, or right after it's quenched, it goes right into a cold treatment. And I know some guys are using refrigerator, dry ice, or liquid nitrogen. So I'm just gonna call it cold treatment, okay?
Yeah.
What is going on with cold treatment?
You know, as I mentioned earlier, that you have the martensite start temperature and then martensite finish, and higher alloyed steels, that window drops down. So the martensite finish transformation is below, well below room temperature in some cases. So that transformation you're trying to get from austenite to martensite doesn't complete at room temperature. The way to complete it is to put it into a cryo or a deep freeze. And that will complete the transformation of austenite to martensite, untempered martensite. Now, in bigger sections, which my company's involved with a lot, that can be dangerous because there's so much stress in the steel if you go straight into a cryo that steel will just pull itself apart. So that's where a snap temper is used if somebody's going to do that. And normally a snap temper is at 325 degrees. That just imparts a little toughness to the steel. It does temper some of the untempered martensite, but then they go into the cryo. So basically, though, with the cryo, you're trying to get as close to 100% transformation from austenite to martensite as you can. But so cryo basically completes the transformation from austenite, which you get up at high heat. It completes the transformation to martensite. Now it's untempered martensite, so after you cryo, you got to temper it right away.